The benefits of keeping the forest standing are not always obvious. In Brazil, research is showing that rainfall thousands of kilometres away is dependent on water that rises into the air above the Amazon rainforest. The city of Sao Paulo, thousands of kilometres to the south, is one of the surprising beneficiaries.
We operate in 366 municipalities, providing water for 26 million people here in São Paulo state. In the metropolitan area, most of the water comes from the rain, from the sky.
Each of the 26 million people who live in the Sao Paulo region uses an average of 200 litres of water a day, generating an annual turnover of $7 billion for the state water company. Flying rivers, air currents carrying clouds from 3,000 kilometres to the north deliver much of this water when they turn to rain.
Right here, we are the meeting points of three waters. The Atlantic Ocean to my left. Right below we have fresh water coming from the river Amazonas mixing with the sea. And to my right we have a huge amount of humid air. Now the trade winds blowing from Africa towards Brazil is carrying this humid air right across the Amazon basin until it reaches the Andes. Then this humid air is forced southbound and in fact is responsible for a good portion of the rainwater, not only for Brazil but for other parts of South America.
The Amazon forest covers approximately 7 million square kilometres and represents more than half of the world's remaining rainforest. The 300 litres of water evaporating daily from every large forest tree, combined with the vapour coming from the Atlantic, means that there is more water in the sky above the Amazon than there is on the ground, according to Gerard Moss's research. It falls as rain over Central and Latin America, providing fresh water for agriculture, hydroelectric power and domestic consumption. Moss, a Swiss engineer and pilot, aims to chart the course of the flying rivers that carry clouds from Amazonia over the rest of South America.
So my flying consists of accompanying the flying rivers. Now while in the flying river, we extract them out of ambient air. We channel it in the aircraft through two glass tubes, which are then refrigerated at -80 degrees. This allows us to separate one small droplet of water. Now that allows us to determine whether this droplet came, for instance, directly from the sea or came from the evaporation of the trees. And in effect, we are determining the origin of rainwater for Brazil and other parts of South America.
In most of the southeastern part of Brazil, most of the water, in general more than 50%, in general over 70% of the water, actually comes from inland. In fact, if you trace back this water, eventually it also came from the Atlantic Ocean. But quite often you get a substantial amount of rainfall, of moisture that comes from the Amazon, straight from the Amazon.
We have good reasons to believe that approximately half of the atmospheric water present in the skies of the central part of Brazil actually come from the evaporation or transpiration of the Amazon forest.
What will happen with the river of moisture if there's a substantial land use change in the Amazon? Will it have an impact in the rainfall in southeastern Brazil, for instance, or in northern Argentina? Models that consider, for instance, the replacement of the forest by soybeans or pasture tend to reduce precipitation in the Amazon basin between 15 and 30%.
The irony is that the rainfall that makes agriculture so profitable here is threatened by the conversion of forest to farmland.